our last was not the link of the meeting was not provided, so it's not available on the GitHub. So share screen. So I suppose you can all see my screen. So last week, what we saw was visualizing distribution and proportion. So we saw how you can use um, how you can use histogram to see uh, to to see what distribution you have in the data, what are the relationships also between two or what are the proportion between your any two variable within the data. And we saw some data set on what's that? I think we can find it here. Yeah, on birds. Yeah, so we saw how to plot visualization for both data that is numeric and data that is also textual by converting the data or aggregating the data to be able to plot such visualization. So today we are seeing relationships. So most in I think most of presentations in secondary school or whatever, you'll be told that there is something called X and there is something called Y. And usually when you are plotting any graph of X and Y, you determine what is the relationship, how X usually influence Y, because most at times Y is the independent variable and X is the dependent variable. So any change in X, how does it affect Y? So in here too, this is some sort of the visualization that you'll be seeing, how two variables, how to any variables, or how to any data sets, or how any two, in the English is not how any two data sets or how any two variables relate to each other. Because as you know, most of the data set that you will see in the world or you will be working with, they do have some sort of relationship in between them. So if you may look at maybe the amount of rainfall in a year will determine maybe how much food is being planted and harvested in that given year. So you see the output of the plant and harvesting is dependent on a variable called the amount of rain, but also amount of rain can also determine the traffic, because if there is, let's say, a whole day it's raining, less people will go out. So in there, you see the data about the data about the amount of rainfall determining how heavy or light the traffic is. So these are some sort of things that you will be working with or looking at when you are talking about visualizing relationships. There are instances where I was given a data set about a particular university and how much electricity they do consume, like for a month. And I think it was about 100 million naira every month that they do consume. So what they were trying to get is to get an idea when it started to become 100 million. But also because there are a lot of statistics, a lot of data, what it does the actual cost to the school, what sort of variable in the data set translated to that much cost. So some of this data that you will be seeing, a lot of it will have variables that are dependent on each other, but there are instances where the variables are not dependent. So if you plot the graph, you may see there is nothing between this. Or if you plot the diagram or visualization, you'll see that there is no any relationship between these two and the rest. So in this tool, in this lesson also, we are using Seaborn, and I think we installed Seaborn in our last presentation. So we read the data. The data that we are using is the honey data. Is I think should be present in your. It's a kind of funny that I couldn't find the data on the on the RUIDS GitHub page, but then on the parent page where the course was adopted, the data is there. So Simon, if we may get this data, please, in a way that it will be easily accessible to the others.
Okay. Noted.
Okay. Yeah. So in the data set, you have a different sort of fields. We have the state as a variable, Alabama, Arizona, Arkansas, it is California, Colorado, I think. So a lot of states, maybe representing even the whole 50 states in the US. And a lot of this data, as you see, we are working with data set, but the data is not even, does not belong to Arewa. Talk less of being a Nigerian data or an African data or the rest. So because a lot of data set in Africa are not available. So some of our work, especially in house NLP, which maybe you have had it, is developing resources for the use of our communities. So if you may, you can also do that. And some of this data, as you see, because they're talking about honey, maybe in our agri department in schools such as BUK, BU, and Northwest, whatever, that do have research on such data will have this data, but it's not easily accessible. So if you may have a contact or two where you can get this data and make it available so that research also can use data sets that belongs to Africa. So, but in here you have state column, the yield per colony, number of colony, sorry. So the state, the number of colony of the bees, the yield per colony, the total production, the stocks, the price per LB, I think was a pound. I think pound is LB. Then the the produce value, if it's that, yeah, and the year that this data was recorded particularly. So it dates back to 1998 to when some of us were not even born. So here to visualize the relationship between, let's say, price per pound, which is price per pound here, and its origin. You can plot a Seaborn scatter plot such that you see here before we plot us, we can find, you see there are the states and then the price. So for each of the state here, you see, well, Wyoming, they have the range in, if you are in Wyoming to buy a pound of honey, you have to spend about, I think, 0.6 to about 2, since we are talking of the US, so we say dollar. So $2, between $0.6 to $2, you can find a pound of honey in Wyoming. And if you see, there are certain places where it's becoming like much more costlier, such that there is high HI, or there is also VA was VA. Oh, these states have funny abbreviations. So yeah, so you see, this will give you like a range of price. So if you are in New Jersey, what, depending on also what type of bee in there, so you get in New Jersey from about 0.5 up to New Jersey. Where is New Jersey? Up to about $4 to get a pound of honey. So in here you are looking at per state, how much do you need to buy to buy a pound of honey. So this is a particular plot that you can find. Also, you can compare also the relationships also between some other fields. But in here, we just see between a state and the price that you need, or the amount of money you need to have to buy in each particular state. So, but also here, it seems like some sort of jar that you may find it very difficult to understand, because it seems like it's getting, even though this first dot and the second dot do not have the same price, but then they have the same size. So a person that is looking at this, if not the person that did the plot, might have a hard time even understanding what you mean here. So the person will have to start thinking about what you actually mean. So you may ask the plot to give you in different shades of color, such that the darker the color, meaning the more costlier the honey is. So, but let's plot our first, which is just something similar to what we just saw on here, or even in the GitHub. So here, what we use, you can use the hue as the year, and then the palette to determine the coloring. So you can also experiment with different palettes. So you see here, it's as it gets darker, it means it's costing more also. So also, in addition to using color, you can also use size to indicate how. So it's price per pound, and also the state, and the year will indicate the size. So meaning across Alabama, as the year increases, the amount of money you need to buy a pound also increases. So if you look at the legend here, you find that in 2000, the price is somewhat small, and as it gets to 2012, it keeps increasing the cost. So for each state, it's not that you need 0.5 here. So let's take South Carolina because it's the last state here. It's not that you need from 0.6 to about £2 to buy that honey. It also means, as this the cycle is increasing, it means the year that you are determining the cost also affect the cost. Not necessarily that it's just maybe in 2000 you buy a pound of honey, let's say at $1, and maybe in 2012 you buy it at $1. In 2014 you also buy it at $1. It might be that in today you buy it at $3, but maybe 2023, which the year we just passed in, it was still $3. Maybe 2022 it was $3, but then at 2021 it was $2.50. So in here you will be seeing some sort of pattern. In Nevada here, there is like the price is about $1.5, but then it decreases and then it increases around, if we may look at this, yeah, it increases to about $2 in the same year. But also in other years, in 2000, it was costing a lot less. So in here, you are trying to give something that is meaningful. It's not that I may say, if you go to Kano, you will find the price of buying honey between 1,000 and 2,000. What makes that 1,000 and 2,000 change? Maybe it's the time, because now in Nigeria, you buy something today and tomorrow the price changes. So it might be that it's just because it's not today. That's why they just increase the price. It might be that there is another factor, maybe the transportation that they do expend to get that honey. Maybe that's what makes the price become higher. So there might be several factors, and most of these factors will have a relationship between them. So the relationship between today and tomorrow. So if I say the price of honey is 0.5, I think the most obvious question that you'll ask is the price of honey when? Is it the price of honey last year or the price of honey this year? So in there, part of the visualization that you are expected to give people to see is the relationship between when does an event occur and what is the actual value of whatever you are trying to find at that point. So from the first graph that we plotted, that is showing nothing. It's just showing you that in Illinois, to buy honey, you have to spend between $1 and let's say $5. You have to spend between that. But then you might see, is it that in Illinois, because Illinois maybe they might have different, let's say, convenience stores where you can buy what was this called, where you can buy honey. So is it that in store one the price is different than in store two, or is it that maybe it's the same store one but the price is different this week and then the price is different next week, and as we continue. We have Abubakar Saidu. Can you please off your camera? Abubakar Saidu. Saibu, sorry. Abubakar Saibu. Yeah, thank you. So this different sort of information will give you will differentiate between how good your own visualization is with another person's visualization. So each of you might say, yeah, plot is scatter plot showing the relationship between state and the price of honey. So all of you will just draw something like this and you've passed. Yeah, if the requirement is passing like this, you've passed. But then another person's visualization might contain some information that yours do not contain, especially if that person is being creative. And for every data scientist, the idea is to be as much creative as possible so that at the end of the day, you convey the most meaning out of a given data set that you are given. So if I give you the same data set, like for all of you that are attending this class, and I ask you, go and just plot without telling you necessarily what to plot, maybe all of you will come and give me different information about the data. And all of those information are very, very useful. But then if you did not copy yourselves or you do not have, let's say, a head start, you may look at the problem at uh, uh, through different perspectives. So, and this is what the data scientist is all about. The data scientist, the person that maybe will score the highest will be the person that brought out more meaning out of the data set, especially through visualization, because that's what we are doing today. So you can see the size of the dots are gradually increasing, but why? Another way to visualize is to use the size rather than color. For color blind, it might be a better option, but why did we use color scheme? So with this color scheme change, you can see that there is obviously a strong progression over the years in terms of honey price per. Indeed, you have to look at sample set in the data to verify. Pick a given state, let's say Arizona, and then you can see the pattern in the pricing. So let's take a state called Arizona here and see something about the data, because here, all of the data that we saw is about all of the data set, including all of the state. So we might give this honey where honey at state is equal to Arizona, and then we plot the head. So let's see this. So you will see in Arizona here, we have some sort of data, but let's say HN is equal to this so that we see the size of the data that we are dealing with. No, no. So print the length of honey. but also honey.head. So the data set is 15, and I think if it is 15, we can see all of the data. I think we have enough space to see all of it. So the state Arizona, we have 15 entries in Arizona, and you see the price per year. So in 1998, it was 0.59, the price. But then in 1999, it reduced to 0.53. Then in 2000, it increased to 0.57. It then continued increasing. And then the price decreased, but also it increased slightly, it decreased, increased slightly, but it went back to. So the price in 2012, it was $198 per pound. So it was like the most expensive it could have gotten, which is 1.98. But as you see, the price were fluctuating. So this price, and in addition to the year, will give you an understanding about this fluctuation. But if you plot the first graph, you just see the fluctuation. Yes, there is fluctuation. If we go to where is Arizona, I think it's in second entry, Arizona, you see that there is fluctuation between 0.59 and 1.98. But what causes the fluctuation, you didn't know. But when you plot it with either the color palette or the size or the year as your size, you will see that it went up in certain years and it went down in certain years. And then you can be able to see this. So these are the, we can, I think, we'll go further. These are some of the things that you be looking at. And some of these things comes with the experience with how much you do this, not necessarily that you just do it once and you forget about it. And then you think that, yeah, I can still do it. No, whenever you are doing it, you will be learning a lot of things, and it will be in your head that if you have so data, these are some sort of visualizations that if you plot, you will know what those some more information about the data. So there is this question also here. Is there a clear rise in the price of honey per pound over year over year? You can most easily discover that by creating a single line chart. So you are plotting price of the honey per year. So price of the honey, which is this, price per LB for the year. So because Seaborn is aggregating data in one line, it displays multiple measurements around X by plotting the mean and then 95% interval around, confidence interval around the mean. So this is time consuming, and you can disable that by saying CI equal to none. But then here, what you are trying to find is as the year increases, meaning in 1998 to 2012, how much does the price rose between this range of years? So this diagram will have told you that it was around 0.8 in 1998, but then the average price around 2012, it was around 230 or $240. $2.40. That's what I mean. So as you see here, you are seeing the relationship between the price and the year. As the year increases, does the price increase? Such that I think most of us here that did pass through secondary school, in addition to the graph that I talked about the relationship between the value Y and the value X, there is also those, I think, graph about demand and supply, where whenever the price increase or wherever the quantity decrease or whatever, this and that. So yeah, so you are seeing the relationship between the quantity of the product in the market, if we are talking about supply, and the price. So if there are more things in the market, if we take the dollar as example, if there are a lot of dollars circulating in Nigeria, the price of dollar will fall down. But if there is a little dollar circulating in Nigeria, there will be competition, and that will drive up the price. So these are relationship, and I think by now we don't need to continue stressing more about what its relationship is with that. So here we plot the price of this, and this is just looking the same. If we give, let's say for Arizona, we have honey, because we did selected Arizona already. We can plot for only Arizona. And if you see, this is the plot for Arizona. It's not the mean across all of the states. It's just for a particular state. Because above there, we selected the data set that contains only Arizona, the state of Arizona. So, and this is the plot. And if you see, it looks similar to the main graph here, which is the average of all of the states. So here, these are visualizations. You can visualize saying price per year for all of the states, or for some of the states, or for wherever. I think we also will be seeing that for this. So, well, in 2003, we can see a spike in the price of honey. Here is 2003. This is where it spiked, and then it fell down considerably, I think, around 2004, 2005. And then after 2005, it started this thing. So, well, in 2003, we can see the spike in the price of, in the honey supply. What if we look at the total production over the year? So, seeing total production over the year. So, this is it. So, the price, the total production was just coming down, 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 down. I think almost across the year, it was going down. But if you compare these two graphs, in 2003, the price spiked because the quantity dipped. That's why we say the explanation or whatever this thing around, if there is more quantity, there is less price. If there is less quantity, there is higher price, and whatever. So you can see what caused this spike in the around. You see, it started around 2001, then 2002, then 2003. It spiked like considerably, and then around 2003, it started falling down up till 2005. So if you see this graph on the right-hand side, it's around 2002, the quantity dipped, but then around 2003, the quantity went up. So that's why the price was coming down. It went up, but when it continued coming down, it continued going up, going up, going up. Although there is an anomaly around 2010, here you see the price was going steep between 2005 up to around 2009, but then it flattened a little, because maybe of the increase in the quantity that was produced. And then since the quantity was just going down, the price continued increasing. So maybe there are less bees, honey bees that are around that produce less quantity. And then since there is less quantity and there are a lot of people that want to buy honey, the price increased. So these are also relationships. So you see the relationship between the total production and the price. So here we saw all of this in single graphs. We'll see where you can draw multi-line graph, so that you can see visually in one graph the relationship between the price and the quantity. But also here we can plot facet graphs, grids to take your data set, and each one you can make you can plot the number of colonies with the year 1999, how many colonies, 2000, how many 2002, I think. No, 1999, how many colonies also. So you can draw multiple graphs. Here we are drawing only one graph. You can use facet here to draw multiple kind of lines. Sorry, I forgot to close this. So this is drawing the graphs for us. Yeah. So you can see you've drawn a lot of graphs in one graph. So subplots. You've drawn many subplots in one plot. So, and it's given you the relationship between the number of colonies and the year. So the year here is 1998, and you see how the colonies were fluctuating. The number of colonies increase, then they decrease, they increase, then they decrease. So for each year, you can see how the number of colonies yeah. So this is facet. If you want to visualize, so if we look at here, we can say which year. Yeah, so for all of the years, it fluctuated a lot. Yeah, the number of colonies fluctuated a lot for all of the year. So if there is any information here that you may want to find by plotting several graphs side by side, you may use facet to do that. So for this data set, nothing particularly stand out to the number of colonies and their yield year over year. So is there a different way to look at finding a correlation between the variables, the number of yield and the year? So there you also explore. So the dual line plot is it superimpose two line plots on top of each other so that you can visualize some of these things. I think to explain this, if we may plot our own. So yeah, so the red line indicates the number of colonies, bee colonies, and then the blue line indicates the yield per colony. If we like, we can look at the price instead of the yield per colony and the number of colony. But here, the yield per colony, it means is indicated by the red line. If you see it continued decreasing. So for each colony, the number of honey they were able to produce in that year, year over year, it continued decreasing. So also the number of bee colonies that are available. So number of bee colonies that were recorded was virtually the same. Even in the year 2010, there was a slight increase in the number of available bee colonies. So if we are talking about maybe insects that are on the verge of extinction, we see that we are safe with bees because the bees are virtually the same. It's just that their produce or the number of yield that they produce year over year continued decreasing. India, maybe it might be a research that is worth conducting. Why is it that there are the same number of bees, but there are less number of uh, yield? The produce that they are producing is less. So India, the agriculturalists will see maybe what are the other mitigating factors that may improve upon this. So there is a challenge here. You learn a bit about other uses of scatter plot and line diagrams, including facet grids and also dual line plots. So you challenge yourself to create a facet grid using different data set. You can either use different data set or you can plot some of these things using different columns. Example here, we plotted the dual line plot here, and we saw the relationship between number of bee colonies and the yield per colony. You may say as a challenge, now I want to superimpose two-line plot of price and then quantity so that you see also how those two variables relate or interact with each other. So this is the end of, I think, the first of the three presentations. The rest of the two, I think, are just more of discussion, I think. Yeah, making meaningful visualization, yes. So in here, what we looked at were visualization. You saw visualization that shows a relationship, that shows distribution, that shows proportion. So, but what translates into visualization that is meaningful? Do you just do visualization for the sake of visualization? Or do you do visualization to pass an information, especially to a person that don't know the data set don't even know what to do with the data set. So you as a scientist or a data scientist that you are given the data, uh, how do you create something that will, one, be enticing to the person that is looking? Most at times the person is a layman, not knowing what you do, but then they want to understand what you did with the data. If you give them a CSV or TSV file or an Excel file full of, let's say, 1 million rows of data set with each having separate columns, they don't know anything about that. But if you give them this particular chart that was drawn here and you tell them that around this year and this year, the number of bees were somewhat normal, but then the yield was reducing. Even an agriculturalist will see, yeah, there is a problem here. Why is the yield decreasing, even though there are virtually the same number of colonies that are still existing? Because maybe by common sense, we may say if there is less number of colonies, there should be less yield. But if there is the same or similar, or even in some instance around 2010, more available colonies, but still the yield is decreasing, there is a research gap here that needs to be found. What is causing this thing and whatever. So how do you make meaningful visualization? So first you are told you have to choose the right chart. You have to know where to use line plot, dual line plot, scatter plot, histogram, pie chart, donut, waffle, facet. You have to know where to use all of this. And that, as we started discussing last week, if it is last week, is depending on what problem are you trying to solve? What type of data do you have? What sort of information do you want to pass out? So if you want to show trend over time, as we see here, you draw a line graph. This is a trend, meaning from 1998 to 2012, the yield continued decreasing. So you see this is a trend here. Also here is a trend. The number of colonies that are existing is also a trend, meaning around 1998, it continues, then go down small, then went up, then come down small, then there was a sharp rise, and then a sharp fall, and then, so you see this is showing you trend over some certain time. So you use line plot. If you are comparing categories, you can use bar chart or pie chart. There are a lot of things here. If you want to show relationship, you can use a scatter plot, a line chart, a facet, or a dual line. To show distribution, you can plot a scatter, a histogram, and a box. While for proportion, you can draw or plot a waffle, a donut, or a pie. And you know all of these things. And you were told that if you want to show relationship, draw a scatter plot or a line plot or a facet or a dual line. So what you just start doing is, you know how to draw these things. You are given the data. And since you are given the data, the first thing you do is you determine what columns are in the data, what sort of information is represented by that data. And then you start thinking about, yeah, I want to show relationship between the total produce and the price. Is it that even that the produce is increasing, the price is still increasing? You say, yeah, there is an anomaly there. So then there might be a relationship also, or a factor that is, even though the quantity is increasing, but the price is still increasing. So you then also plot the relationship also between maybe price and another variable, so that you see which of those variables is causing the price to continue rising, even though the quantity is increasing, which is supposed to translate that the price should come down, but it's still going up. So in there, you have to start looking at exploring the data, this, and that, until you find a reason. Maybe then you say, yeah, the reason is this. Or maybe your data set does not cover the reason, because maybe there is part of the data or some information in the data that is missing. So if you go and meet the agriculturalists, and the agriculturalists look at this and say, yeah, the number of yield per colony is increasing. It's decreasing, sorry, but the yield is virtually the same. So they might say, maybe the cross-mating between maybe the animals is low, or maybe there is this that is low, or maybe the animals are not being well fed, or maybe the food that they are consuming, or the feed that they are consuming is not that very good. So he will say, yeah, Why don't we plot this type of weight and then this? Then you may say, no, in this data, there is no information about that. Then you will say, yeah, let's go and collect that information because it's missing, so that we explore whether that's the reason why it's doing this or that. So at the end of the day, you see, these are some of things that you want to tell because you are trying to tell a story. So also you have to avoid this deception. So this is like a very good plot where this was taken from CNN. I don't know whether it's a true plot or it was just formed. It was said that the White House prepares to address such in violent crimes. If you see the violence here, it decreases and then it went up sharp. But the problem with this graph is the years were interchanged. It started to 2021, 2020, 2019, then 2018, which ideally you are supposed to start from 2018, then 19, then 20, then 21. And if you flip this graph, you'll see that actually the crime is going down, not going up. It started to 52%, then it went down to 49, went down to 41, even though there is an increase to 48. Maybe around this time, because this is June, April of 2021, maybe there is an election in that year, or there is something that happened, a protest in that year that makes the crime to jump. So as you see here, you have to avoid deception because this graph will be is deceiving the person or the people that are looking at it. So also here it's showing COVID. The plot is saying, yeah, COVID is going down. COVID is going down. But the problem is if you look at the x-axis here, the dates are shuffled so that the graph will look good. So the actual, it starts 28 April, then 27 April. You see it came down. It's supposed to be 27 April, then 28 April, which 28 April will show that there is like a huge surge in COVID infection or COVID cases. But then they twist the graph so that 28 will appear first, meaning that today there are a lot of cases, then tomorrow it went down, which actually is today that it was low, but tomorrow it went up. So here you see this is just deceiving. It's not passing the right information. Even if that here the graph is being plotted well, but then the data set is manipulated so that the graph will show something that is reasonable. So also here, the flipping x-axis. So you see, ideally, even in a secondary school maths, you start 0 from here, and then you go up. But here, 0 on the y-axis start from here, and then it went down, 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 meaning as it went down, it's going up. So ideally, this graph should be flipped horizontally so that you actually see the graph, meaning it starts from 800, then it came down towards 500, then it go up towards 600, then it came down slightly, then it went up towards 800, but it's coming down, a plateau or some sort of, yeah. So, but here is showing that there is a lot of rise. If you look at this chart, you will say, yeah, number of murders have increased. But in actual sense, it was decreasing from year 1000 to 1990s, then to 2000s to 2010. So this is also deceiving. So also here, there is the inappropriate use of proportion. A lady from Kenya or from India, maybe the distribution of people from India, the actual plot showed, yes, 5.0, but 5.0, it showed that it's just deceiving us, meaning that it starts from 0 somewhere here. In which, if this is actually plotted, the difference in height between people from India and people from Latvia is not that much. It's between 5 inches to 5.5 inches here. But here you see the proportion was enlarged, but it was then reduced here to show that there people from India are that very small and people from Latvia are very huge. So it's the inappropriate use of proportion here. So these are some of things that you have to take note. because some graphs might be deceiving, and do in as much as possible to not use or not be deceiving in your plots. So also, because I said at the end of the day, most of the plots that you'll give are people that don't know anything about the data. So when you give them that, they might look at it and start thinking about something else, even though the data set did not say so. So also you choose your colors, you also style. There are a lot of styling that you may do. If you give me this chart, it may be something that is very meaningful to a scientist, but maybe to a person that is not a scientist, it will just be looking at something that I can just print it on the wall and just post it on the wall, but not necessarily making any meaning out of it. So also you can animate or you can do 3D chart. So in most cases, animation will show you. So let's assume you are trying to take a data set about, let's say, exploration. And in that exploration, there might be some movement under the ground. Maybe after you get all of the readings, you might, instead of just giving still graphs, you can animate the graphs so that a person will be seeing something moving and it will be simulating what is happening actually on the ground. So in that plot, it will make much more meaning seeing that. So also, I think in a lot of cases, if you are watching the weather channels, you will be seeing wind and it will be animating the wind. Instead of just showing arrows that are not moving, it will be showing you some arrows that are moving, showing the direction of the wind, but also if there is anything like a tornado or whatever, storm or whatever, you will be looking at it visually and it will be making sense to you. So these are sort of things that you keep in mind when making visualization. Do something that will be enticing, but also will pass the true meaning that you get from the data, not something that is deceitful. So the last part of the presentation, which also I will be very, very quick to do, is communicating. So can you still see my screen, please? I've been talking, I don't even know whether you're following. Saminu, are you here? So what
Yes,
I will do is I'll
yes,
allow you to be able to unmute yourself, but then please don't abuse it because some people will just,
okay.
yeah. So all of you can unmute yourself when you have anything to say, but please don't just be unmuting for unmuting sake. So then there is communicating this. At the end of the day, most of us here go to conferences or go to where places where people do present. And part of the presentation that you'll be seeing are tables, charts, visualizations everywhere. Sometimes they make sense, sometimes they don't make sense. So that making sense depends on either maybe your level of expertise where it's supposed to reach, you did not reach that, or maybe the presenter is not very good in communicating what he or she actually meant in their presentation. Or lastly, it might be that they used presentation or visualization that did not fit the particular presentation or the particular problem or particular solution that they are trying to convey. So it might be a mixture of all the three, or it might just be one. Maybe there are places where you see people just nodding their head, but they don't understand anything. Or maybe there are places where people will be nodding their head, but only you, maybe you are not understanding. Maybe it's because maybe your expertise is not up to that. So there's maybe little or no solution for you. But at the end of the day, even if you don't know anything about that, the quality of how the presenter communicated whatever his or her findings are will either bring you along, even if it's not like bring you totally along. So communicating. So in this lesson, you know what to communicate. So communication is just telling story. Because at the end of the day, you are given this huge, let's say 1 GB of CSV file, and then you went there and did some data analysis on those files, and then try to find out a lot of interesting facts about that data that you are given that file from, and then you plot all of your tables, summary tables or average tables, and then you plot a lot of visually enticing charts. But then you have to tell the people what you mean. because you don't just give the chart and just say, here it is, and then you just go. No, you have to explain. So on explaining, you don't just start, if you add X plus Y, it will give you this. And then because I did this, divide by this or subtracted by this, and I took the standard deviation of this, a lot of the people will not even understand, because among us here, including myself, how many of us are good in maths? Because I will count myself. What you really want to hear is about the real life issue that was communicated in that data, how that was gotten. You don't care, because most at times you don't even know what it means. What is standard deviation? Can you tell me how to calculate standard deviation now? I have to Google. So if you start Googling before even understanding one sentence in that storytelling, the presenter is not good. So, and in most cases, you, the data scientist, is the presenter. So you have to know what you do. So communication, there is a one-way communication when the sender sent information to the receiver without any feedback or response. And then there is a two-way communication where you give it and then you receive feedback, you give it, you receive feedback. So to effective communication, you have to understand your audience, your medium, and the method that you are communicating. So this, I think, fits the example that I was given. The presentation maybe that you'll do to PhD students will be far different from the presentation you will do to primary school students. Because in primary school, what do they know? They know only playing with dolls and whatever. Here, there, if you tell them Ali and Simbi do this or that, if I am calling Ali and Simbi, maybe in our time, I'm somewhat old now. So they will understand you. But if you go to PhD and you start telling them something of that nature, it won't sit well with them, even if you are telling the same story. But the medium to which you pass the story depends on also how you communicate. So you get your audience, you determine what medium are you passing. Something that maybe I may give you here, because there is a two-way communication. I'm telling you something about presentation, about visualization, and you are listening to me, you can ask questions. So it's a two-way communication. There are things where I just record a video and put it on YouTube. I try to be as much explicit as possible because I know I'm not there to answer the questions. So that's also a medium to which I am communicating. I post something on Facebook, I'm communicating. I may say, yeah, let me reply to this or this or that. But sometimes what you say, people will understand you in a way or that other way before you even are able to clarify yourself, because the communication is mostly, in most cases, one way. It takes a lot of time. So begin with the end in mind. If you just start talking, what do we want to achieve here? We want to achieve knowing visualization. That's why we started from introduction to visualization. Then it was structured that you see proportion, then distribution, then relationship. Because at the end of the day, what do you want to learn? You want to visualize your data set. So that's the end. Then you start talking about the means. Some people say the answer is by the means. So you approach it like an actual story. Most of us here will follow this well if I start telling you a story. And in that story, there is that information or that lesson that I want to pass. But if I start telling you about hydrogen, oxygen, maybe before I even finish the first sentence, you will have fallen asleep. Because the actual information is not about the hydrogen or the oxygen. The actual information is somewhere in between. But if you are given it as a story, that here, you know, if I may talk about, let's say, such in crime, I can start, yeah, in 2021, there is an election that happened. So India, there were this and that. You see, I was given a story, and when I mentioned election, a person will start thinking about what happened during that election, because we are talking about crime. So that person will start envisaging that, yeah, around that time, there should be upsurge. But then I tell him now, around that time, the crime reduced. So that person will start, maybe he will start challenging me. No, how will that reduce? Ideally, it's supposed to increase. So that means our data set is defective. So in there, you see, you are bringing the person along, you are telling them a story, stories that make sense, he will agree with you. Those that don't make sense, he either gets feedback or engage you in one or two chats, so that you get to understand each other. Or in some certain instances also say, yeah, this data is not reliable. At the end of the day, the decision is between you and him. But if you just start telling him yeah, there is this line went up, then down, then up, then down, what are you saying? So you use also meaningful words, also talk to their emotion also. So these are how you communicate. I'm not teaching you, I don't know anything about communication, but Assalamu alaikum, Saminu.
Wa alaikum assalam, Doctor.
Sorry, my internet went off, so I had to
Yeah.
rejoin my phone. I think we've reached the end of the presentation. Were you with me when we reached the end?
Hello?
Can you hear me?
Yes, I can hear you.
I said I think we reached the end of the presentation, cool?
Yes, I again you are adding something, so but it's already done 6 minutes after 3.
Okay.
So
do we have questions that we need to answer, or do we just meet in the Telegram group?
Good afternoon, sir.
Good afternoon.
Sir, my question is pertaining to the assignment, sir.
Yes.
The assignment for pandas is much. Is the assignment for pandas the same as the assignment for data visualization?
Sammy, please help me here. Bala will have been in a better position to answer. I don't know,
yeah.
Bala, are you here?
No, it's like Bala is not here, and maybe please you can ask the question in the channel, and then Bala will respond appropriately.
All right, thank you.
Assalamu alaikum. Coordinate the course. So most of these questions he will be in a better position to answer, because all of the logistics he might be well aware of them that I am not, maybe. Yeah, Sharif.
Please allow the previous speaker to make his question so that Simon one or the mentors can answer him.
Yes, I think that is what we said, Doctor, that he should let him ask the question through the channel, and then he will get a response accordingly.
Okay, yeah.
Sharif.
Good afternoon, everyone.
Good afternoon.
Yeah. So my question is in terms of the collection of the data. Like, for instance, now if I want to know maybe what are the total number of youths that are unemployed in Nigeria or something like that that relates to Nigeria, like how is it done? Is the government that is responsible for for collection of data, or are the data scientists responsible? For instance, most of the data we used are being gotten from maybe the US and other countries. Is it that is the government that collected it? Or I don't really get the scope of how data are being collected.
Yeah, so if I may respond to your question, I think it's a good question, because I was introducing the challenges we have in the shortage or even unavailability of data sets. I was imploring you guys to be to also create the data, but sometimes creating the data is very, very difficult, The amount of money you will see that you will spend to create just a small data will blow your mind. Because access to such resources sometimes is only feasible if the government are willing to do it. So if you go to, let's say, Nigerian Bureau of Statistics, NBS, there you might find maybe the inflation statistics, the number of unemployed, the unemployed, the whatever. In there, they have offices for that their representation is each state of Nigeria. Maybe the state you are in, you might say, yeah, let me even go to one local government and try to find where will you get that data. You have to spend a lot. Sometimes getting data involves doing either interview, questionnaire, or whatever. And sometimes you just have to sample. Maybe you say among your own district, if you live in a district, maybe you go to, let's say, 10 houses or 15 houses by just random sampling, if you may. And then in there, you draw generalization from that data or whatever. But data collection actually is like very much expensive, but also in certain instances, it's not even doable. Because let's say yourself, Sharif, you want to know how many people are unemployed in Nigeria. You have to go to the 36 states of Nigeria, including the FCT. And then for each, you have to sample each local government, because one local government's conclusion might be different from another's. And in there, then you might say, yeah, now I have the data that I can use. But then imagine how much effort will you put, how much money will you spend? So sometimes there are some sort of data that you may say it can only be gotten by the government. But there are some that you may say, yeah, maybe between the three lines in our area or three street you call them street in our area, let me find out how many people are unemployed, so that maybe in 2022, how many of my colleagues are unemployed, 2023, how many are now unemployed, 2024. So you see that data is like very small, that maybe you can use it to do some sort of analysis, but for your own street and maybe the next street and the other street. But for Nigeria, you see, like is like a budget that will consume a lot of naira, if not dollars, but also a lot of effort. Even if you can do it, then maybe you have to employ people to do it for you. So Sadiq, please, the last question so that we just round up.
Good afternoon, sir.
Good afternoon.
Yes, so my question is regarding the data camp courses. I've seen that it's almost like 23 courses. Are you going to finish all the courses before the break? Because you said that
Bala, please, can you come in here, Bala?
Yeah, I'm here. I can talk.
Okay, doctor.
Right. So, yeah, thank you for asking the question. So I think last week we made it clear, is it last week or week before last, that we do understand that we have only 2 weeks that we gave, that we want people to do the data camp course, but we come up with another different, strategy. The thing is, data camp, we have around 23 courses or 20 something about that. So moving to the next stage of machine learning, you need not to necessarily finish the 10 course we already made mention. But the idea is, as we finish the machine learning course, the last course, everyone should have complete all the data camp course. So by the time we finish the machine learning course, you complete your data camp course, and then that's the only way you will graduate. At the end, when you finish the data camp course, we will assign you to take the professional certificate, data scientist professional certificate, which you will only take that one after you complete all the data camp courses. Then you will get your certificate for Ariwa DS, and then you also be assigned for mentors afterward, that you continue to grow, to learn more. So the idea is, when we give you these 2 weeks to finish this half part of the course, some of you may rush to just finish the course without fully understanding the concept. So we make it, free, that you can move on to the next stage, provided you finish what you have been assigned. And the compulsory finishing will be only when we finish our machine learning. So you still have like around I think 8 weeks that will start machine learning. So machine learning is 8 weeks. So you still have 8 weeks to complete all the courses. So I hope that makes sense.
Yes, sir. Thank
All
you,
right.
sir.
Thank you.
I think it's already past the hour. If you have a question, please ask it on the Telegram chat. It's already 14 minutes past the hour, and I think most of the questions can be answered there. You will be even given much more information there. So without much ado, Simon, I will leave you as the host, and please close the meeting for us, or if Dr. Shamsu would like to do that.
Oh, okay. So today we don't have a session. I thought we are finishing the visualization. Oh, you already did that.
Oh, yeah.
Did what?
I thought
This
we
session.
have some part to finish for visualization.
No, we finished everything on visualization.
Oh, now it's
It
3,
was
right?
supposed to be finished on Sunday, but then I was not able to attend because I had to go
I
out.
understand. Now it's 3 o'clock, right?
It's past 3.
Here where I'm now is 2 o'clock. So I just get confused. So I thought like the session start now.
No.
Sorry, it's already 4 here.
Hey,
Okay. All right. So thank you.
Okay, so thank you,
All right.
everyone. And then
Thank you.
Simon.
All right. So thank you, Doctor, for the presentation, and thank you, fellows, for joining us. Do join us tomorrow, inshallah, so we'll continue the journey of data science and machine learning. Thank you. Bye. If you have any question, please don't forget to put it in the Telegram channel, and you will be answered, inshallah. Thank you.